Significant figures allow us to show the accuracy of a measurement. Many times in science, we'll take multiple measurements and do a calculation based on these. Well, in the same way that they say a chain is only as strong as its weakest link, the product of a calculation is only as accurate as the least accurate of the measurements involved. How we look at this accuracy depends on whether we're talking about multiplication or division, or addition subtraction. Let's look at addition subtraction. In addition and subtraction, we're going to look at the number in the calculation that has the least number of decimal places. So let's say we have this, 52.368 liters. Notice that this has a digit in the tenths, 100ths, and 1,000ths place. And we're going to add to that 4.1. 4.1 liters doesn't have any digits in the hundredths or thousands place. So when we do this calculation, our calculator will bring up this value. But what we have to do is we need to round this to the number that has the least number of decimal places. That would be the 4.1. So this becomes 56. We're going to keep this 4, but round it based on the next digit, and that's the 6. So this gets rounded up to 56.5 liters. Let's look at another example. Let's say we have 53,500 milligrams, and we're going to subtract from that 1,256 milligrams. In this case, we have 53,500, and then we're going to subtract 1,256. Well, I can see that the 53,500 doesn't have anything in the tens or in the ones or the tens. It just has zeros. Whereas the 1,256, it has digits that are significant all the way down to ones. So when I do this calculation, I get 52,244 milligrams. But I'm going to round this final answer to the hundredths, or to the hundreds. And that means that it's 52. I keep this 2, but I'm going to round down because the next one is a 4. Now, what I have to do is I need to put zeros in place for those 2 decimal places, or decimal spots. So I get 52,200 milligrams.